Hey guys, welcome back to the channel. Have you ever thought about how dependent we are on electricity? If not, then try going one day without it. That means no computers, no cars, no TV, no refrigeration, no wristwatches, no electric lights, no phones, well, you get the point. But the dependency of our civilization on electricity is not something we can do anything about. After all, we need it for our advancement. Thus, to meet the ever-growing demand for electricity, a necessity arises for the production of electricity in large amounts. There are various ways to produce electricity. For example, hydroelectric, coal, oil, natural gas, solar, wind, tide, biomass, geothermal, and nuclear. In power plants, the generation of electric power is usually achieved by the use of electromechanical generators. Heat engines can drive these generators, as in the case of burning of fossil fuels and nuclear fission, or the kinetic energy of flowing water or wind can be used for driving the generators. But the combustion of fossil fuels like coal, oil, and even natural gas emit carbon dioxide, which results in global warming. Also, such sources are non-renewable and their depletion increases as our needs increase. Moreover, for renewable resources, the sun doesn't always shine, nor the wind always blows, nor does the water always fall through the dams. But nuclear energy comes to the rescue here. Nuclear energy is the most reliable energy source. A factor called the capacity factor measures the percentage of time for which a power plant actually produces energy. Nuclear energy has the highest capacity factor as compared to other energy sources. This is because a nuclear power plant will stop producing power only when it is under maintenance or refueling. Nuclear power is generated when the energy from nuclear fission is used to generate heat. The heat generated is used to power a steam turbine, which in turn generates electricity. At present, the majority of electricity from nuclear power is produced by nuclear fission of uranium and plutonium. Nuclear fission is a nuclear reaction where the nucleus of an atom splits into two or smaller nuclei. The splitting of an atom produces some byproduct particles and a very large amount of energy. The amount of energy released in a nuclear reaction is more than 100,000 times greater as compared to a chemical reaction where the rearrangement of electrons take place. Although there is a general concern over safety when it comes to nuclear power, it has one of the lowest levels of fatalities per unit of energy when compared to other energy sources. In fact, using nuclear power in place of fossil fuels prevented around 1.8 million air pollution-related deaths. Also, coal ash emitted from a coal power plant as a byproduct of burning coal for electricity carries more radiation than a nuclear power plant producing the same amount of energy. Thus, nuclear energy has the following advantages. First, carbon emission values of nuclear power are comparable to or lower than that of renewable energy. Second, nuclear power is one of the most efficient energy sources. Also, the average dose of radiation from nuclear power plants to the public is 0.0002 millisieverts per year, which is 10,000 times smaller than the total yearly dose received by the public from background radiation. In spite of its advantages, nuclear energy also has some disadvantages, like the possibility of accidents leading to leakage of radiation in the environment, although the possibility is low and it's decreasing. Environmental and health issues related to mining and refining of uranium, storage and disposal of the spent fuel, and transportation safety of nuclear waste. Well, that's all for the introduction to nuclear power and its advantages and disadvantages. We'll be back soon with more videos on nuclear reactions and nuclear reactors. Until then, bye.